Hello everyone, myself Karimunnisa Shaik. I am from IT department. Today we will discuss about the machine learning subject. In that machine learning subject, we have first introduction. First, what is this? What is the syllabus we have? This is the unit 1. In the unit 1, we have types of machine learning, supervised on the brain, the neuron, designing a learning system, and the perspectives issues in machine learning, and the concept learning task. Concept learning as a search. We have a finding maximally specific hypothesis, version spaces, and the candidate elimination algorithm. And the second part is in unit 1 only, decision tree learning. We have a introduction and decision tree representation, basic decision tree learning and hypothesis based search in decision tree learning, and inductive bias in decision tree learning. What are the issues in decision tree learning? Coming to the objectives, this course explains the machine learning techniques such as decision tree and Bayesian learning, etc. In this, we have these types of learning methods, and to understand the computational learning theory and study the pattern comparison techniques. Next, what are the outcomes we have? We need to identify and the difference between the supervised, unsupervised, and semi-supervised learnings, and the relationship between the brain, neuron models, and the learning systems highlights their computational perspectives, and formulate the concept learning task, apply the hypothesis search techniques, and such as maximally specific hypothesis and version spaces, and implement the linear models, including linear discriminants and perceptron learning, linear regression for classification and prediction. Evaluate the issues and perspectives in machine learning system design by considering challenges such as linear separability and algorithm limitations. Next, what is machine learning? The term machine learning was first introduced by the Arthur Samuel in 1959. Machine learning is a branch of AI where computer making decision without being explicitly programmed. Next, in the machine learning we have AI and ML and deep learning. AI enables the machines to think without any human intervention, and machine learning is a subset of AI, and deep learning is a subset of machine learning. Next, traditional programming versus machine learning. In the traditional programming, we are giving the data and the program, it gives the output. In the machine learning, we need to train the machine. We are giving the data input and output we are giving. Based on that input, it classifies the output. It gives the output and the program. We are training the machines. Next, in this, how machine learning will work is we are taking the training data and train the ML algorithm. We have a supervised learning algorithms and unsupervised and unsupervised and semi-supervised learning algorithms. First, we need to give the training data. After that, model the input data. What type of data we are giving? First, it needs to model it identify the model and it gives the output. It gives the output based on the input data. Next, it predicts the successful model. What we are giving in the input is it takes the input and train the algorithms. After that, it gives the output based on the what we are giving the input. Next, what are the advantages of machine learning? We have an automation, continuous improvement, reduces the need for manual programming, and continuous improvement learns and improves with more data. High accuracy can make better predictions than humans in many cases, handles the complex data, works well with big and complex data sets. Next, saves time, speed up decision making process. Pattern recognition detects the patterns that human may miss. Real-time processing can analyze and predict instantly. That is nothing but fraud detection. Reduces the human errors. Decisions are data-driven, not biased. Next, what are the disadvantages of ML? First one is data requirement. Needs large amount of quantity data. High cost. Development and computations are expensive, time-consuming. Training models takes lots of time. Overfitting risk. Model may perform well on training data but fail on the new data. Next, we have a security issues. vulnerable to cyber attacks. Maintenance needs regular updates and retraining. Next, bias in data. If data is biased, results will also be biased. Next, what are the applications of machine learning? We have first, in traveling field, we have many applications. In marketing field, we have many applications. In social media, we have many applications. In automation, we have many applications, etc. In healthcare also, and sales, credit insurance, we have many applications. In marketing field, we are taking the lifetime value of a customer for prediction. Next, in cross selling, how much the cross selling will be there, and upselling and churn. Next, in social media, we have a digital marketing and sentimental analysis. This comes under the machine learning. And automation also, we have a self-driving cars and pilots aircrafts and drones. In traveling, predict the flight delays and dynamic pricing. Next, in healthcare, disease prediction and medication effectiveness. And the sales is discount offering and demand forecasting. Credit insurance is claims prediction and fraud risk detection. In the applications of machine learning, we have a virtual personal assistants is Google Assistants like Siri. If we call, if anything we need to ask Siri, it will give reply like Amazon Alexa and Microsoft's Cortana. In traffic predictions, we have a Google Maps, Bing Maps, and Maps.me. Social media personalization, product recommendation for next time, email spam filtering. Next, in the applications, online fraud detection also one of the application, and stock market trading, assistive medical technology, and automatic translation. Next, what is well-posed learning problem? In the well-posed learning problem is we have, if we are doing some task is that can be represented by a task T, and what was the experience we gain is E, and the performance, what was the performance we have done is it measures with the P. If its performance at task T measured by P improves with the experience E. The task can be represented by a T and measured by a performance represented by a P, and gain some experience that can be represented by a capital E. Next, in well-posed learning, we have taken one example, that is a checkers learning problem. Checkers problem. That is, the task is playing checkers and the performance is % of games won against the opponents. How many games we have won against the opponents is the performance measured. The training experience is playing practice games against itself. Next, we have another example, that is handwriting recognition learning problem. Task T is the recognizing and classifying the handwriting words within images. Performance P is % of words correctly classified. Training experience is a database of handwritten words with a given classification. Next, we have another example, robot driving learning problem. The task is driving on bubbling 4-lane highways using vision sensors. Performance measure is average distance traveled by before an error, and training experience is a sequence of images and setting commands recorded. What are the commands recorded? Next, and coming to the types of machine learning, we have 3 types of machine learning techniques. One is supervised, and the one is unsupervised, and third one is reinforcement learning. In the supervised learning, we have a example algorithms are classification and regression algorithms, and unsupervised algorithm we have clustering, dimensionality reduction, and association rule. First, coming to the supervised learning. A supervised learning is a AI system is presented with the data which is labeled. In this supervised learning, we have using labeled data. Next, take an example. We have initially taken some data and marked them as spam or not spam. We have taken a data, spam and non-spam data. This is a labeled data used for training the supervised learning. Once it is trained, we can test our model by testing it with a set new mails and checking if the model is able to predict the right output or not. First, we are taking the input is spam or not spam input and learns the machines, and it gives the if any we are giving the another input. If that input is takes the spam or not spam, it needs to identify and it gives the output. Enables the machines to be trained to classify the observations into some class. In supervised learning, another example is we have given a apple image that can be and the features and the apple and the orange image and the name as orange. In the supervised classification, decision function hypothesis. If we are giving the inputs, it classifies and it gives the output as the color and the attribute what we have given. If it is an apple, we are giving the apple structure and the color and the features of apple. It matches, it gives the output. If it doesn't matches, it gives the related to that input. Next, in the models of supervised learning, we are giving the training test, documents, images, sounds, and features, and the labels data also we are giving to give the machines. It learns and it gives the predictive output. Next, and we have types of supervised learning. Classification is one of the algorithm. Classification and another one is regression. In this classification, we have a similar type of algorithms is random forest, decision tree, logistic regression, support vector machine algorithm. And in regression, we have simple linear regression, multivariate regression, and decision tree algorithm, and lasso regression algorithm. In this, we have classification is we need to classify the problems such as yes or no, male or female, red or blue. We need to classify if it is a yes condition, if it is a positive, then it will be the yes. It is a negative, it will be the no. Next, the classification we need to give. The classification algorithm predicts the categories present in the dataset. Some applications of classification algorithms are spam detection, if the email is spam or not spam, email filtering, etc. Next, integration algorithms are used to solve the regression problems in which there is a linear relationship between the input and output variables. These are used to predict the continuous output variables such as market trends, weather prediction, mark of students. Next, in the some popular regression algorithms are simple linear regression algorithm, multivariate regression algorithm, decision tree, and lasso regression algorithms. Next, coming to the applications of supervised fraud detection, we know that fraud detection and image segmentation, medical diagnosis, speech recognition, spam filtering. In this all, we are giving the input data set, input corresponding output also we are giving, and the another input that is related to the what we have given the input data set. If it matches to any features or any inputs, it gives the based on that output. Next, in unsupervised learning, an AI system is presented with unlabeled data. In supervised learning, we have given labeled data. In this unlabeled data, we have given an uncategorized data. Take an example, we have given some characters to our model which are ducks and not ducks. In our training data, we don't provide any label to the corresponding data. Machines are instructed to find the hidden patterns from the input data set. The unsupervised model is able to separate both the characteristics looking back at the type of data, models, and underlying the structure of distribution in the data in order to learn more about it. Next, here we have giving the duck and unduck. We are giving unsupervised learning. We are giving the data set in the machine. It trains machine. It gives the similar type of data as one group, and another similar type of can be considered as one group. Next, training and text documents we have given, features and vectors are giving, mission algorithm, and based on the features and the images, it classifies the two different things. Next, in these types of unsupervised learning is clustering and association. Clustering is nothing but a group of data, similar data, and association is one of the unsupervised learning technique. It discovers the relationships, patterns, dependencies among the variables or items in a data set. Next, in semi-supervised learning, it uses the combination of labeled data and unlabeled data. In supervised learning, we are giving the labeled data. Unsupervised learning, we are giving the unlabeled data. In semi-supervised learning, we are giving the both the combination of data. Similar data is clustered along with the unsupervised learning algorithm. Further, it helps to label and unlabel the data into labeled data, because a labeled data is comparatively more expansive than unlabeled data. Next, in the another algorithm is reinforcement learning. It is like a feedback based process, learning from the experiences and improves its performance. We are taking the feedback first. After that, taking the feedback, if any changes or if any modifications are happen, learns from the feedback and learns from the experiences. After that, improving the performance. In this, we have past, present, future. All the things are covered by the past and present futures. Next, a agent receives the rewards and by performing the correct actions and penalties, performing incorrect actions. Agent learns without intervention from a human by maximizing its rewards and minimizing its penalty. It's a type of dynamic programming that trains the algorithm using system of reward and punishment. A reinforcement problem can be formalized using Markov decision process. In the reinforcement learning, the environment and the agent can detect the situation and gives the output. Agent can, the input is we are giving the fire, agent can detect the fire and it gives the predictions what we need to do. If pour some water, it stops the fire. First it observes. Next, selection action policy. Next, action what it takes, what it needs to give action, get reward or penalty. And if it is a bad, updating the policies, learning step, and the until an optimal policy is found, until we get the output, it can be done. Next, in the types of reinforcement learning, we have a passive reinforcement learning and active reinforcement learning. In the passive reinforcement learning, the agent's policies is fixed, which means that it is told to what to do. Therefore, the goal of passive RL agent is to execute fixed policy and evaluate it. In this, we have a fixed policy. There is no need of change. Active reinforcement learning, an agent needs to decide what to do. There is no fixed policy that it can act on. An active reinforcement learning to act and learn the optimal policy. Applications of reinforcement: video games, resource management, robotics, and text mining, etc. Next, these are the references. Thank you.